Hi there. In this triangle, we've got a missing angle and some missing sides. Using the sine rule, we can be able to calculate the length BC and the length AB. In this other triangle, we also have missing angles and a missing side. But using the sine rule would make us able to calculate the length XY. Therefore, we need to find another rule which is very important in trigonometry. This is Z Online School. In this video, you and I are going to be looking at trigonometry involving the cosine rule. We are going to do this in a systematic way, and by the end of this video, you must be able to know what is the cosine rule, deriving the formula for the cosine rule, application of the cosine rule. At the end of this video, we've got bonus tips for you. Make sure you watch this video till the end to get the maximum value out of it. Like we may have seen, we're starting with knowing what is the cosine rule. By definition, it's something very long. But if you look carefully at this definition, you can be able to extract the formula that comes about from the cosine rule. As you can see, we've got the square of a side being equal to the rest of the things here. So we know we have a square of a side as the subject of the formula. Then that square of a side will be equal to the sum of squares of other two sides minus 2 times the product of these other two sides and the cosine of the angle between them. Let's just understand this before we get to knowing how we derive the formula itself. We have a triangle. In this triangle, we've got vertices that can be given different names. Here I'm going to take A, B, C. Therefore, it means this side here will be taking a lowercase a because it's opposite the angle at A. This side here will be B, and this other side here that is opposite C will be C. Depending on what we've been given on equation, we're going to take a different kind of the cosine rule. Let's say we've been given B, C, and the angle at A. That will mean that we'll be finding the length CB or the length A. Hence, we're going to use the form of the cosine rule: A squared is equal to B squared plus C squared minus 2BC cos A. If we're given A, C, and the angle at B, which is just the angle between A and C, we are going to use B squared is equal to A squared plus C squared minus 2AC cos B. If, on the other hand, we've been given B, A, and the angle at C, we're going to use this third variation. If we're supposed to find the angles of any of these variations, let's say A, B, or C, it's very simple. You just see 3 sides of the triangle given to you. It's very interesting to know that this formula is what will enable us to find that question that we looked at in the introduction. But before we do that, let's get to know how this formula comes about. We are going to have a triangle just like we had. You should be able to agree with me that these are the vertices and their respective opposite sides. Now, as you can see from the subheading, we'll be using SOHCAHTOA and the Pythagorean theorem to derive the cosine rule. So you should be able to understand that we'll be using this trigonometric function cosine theta, which is adjacent over hypotenuse, and the Pythagorean theorem. Both these formulas here have been covered under the basics of trigonometry. So if you haven't watched that video, it's a must watch. Now, we're going to create an altitude from any of these vertices. For explanation purposes, I think this altitude will be easiest to understand. It might also be just referred to as the perpendicular distance from AB that has been drawn to meet C, or the shortest distance from C to AB. We're going to show it by this small symbol here, which will mean right angled. If you see it in any triangle, you know that angle found there is 90 degrees. Now, creating this altitude means we have a new point on the line AB. We have a point O, and we have another distance which we can call H. Now, we will use these sides we've created, the points we've created, to derive the cosine rule. But It might be easier for us to understand everything we'll be doing if we extracted the triangles found in this triangle. We have two of them. One will be that and the other one will be looking like that. The first triangle will have the vertices O, A, and C. No matter the order, we're still talking about the same triangle. The other triangle will have O, C, and B. Again, the order doesn't matter as long as you have the correct vertices. We're talking about the same thing. What you notice is that both these triangles have a similar dimension or a similar length, CO. You can see CO is present in both. In the first triangle, we have B. In the other one, we have A. Both of them have got an angle here, theta, which can be given in equation. As you can see, this angle at A is the angle here. It might be given. The angle here might also be given here. Note that using this altitude does not make us able to use the angle that's given at C because we've divided into two parts. If we were deriving the sine rule, just these sides and angles will be helpful for us to derive the sine rule. But now, because we're deriving the cosine rule, we need to have a way of incorporating the third side, because that's what the cosine rule brings to the table. It's us integrating three sides of the triangle into one formula. We do that by just giving one of these sides a variable, a length that we want to know. For example, I can take OA to be x. And then since I've taken OA to be x, it means the other side OB can be found if I subtract x from C. Now, I've found a way of including C into my diagram. Notice that this C minus x can also be here, the x can also be there. There won't be any difference. If I take this BO to be my x, it makes sense that if I subtract this distance from C, I'm going to have this other one. Now, with this information, we can now get going. The cosine rule comes from mainly the Pythagoras theorem. Then after we get the relationship between these two triangles via the Pythagorean theorem, then we will come and incorporate this trigonometric function cosine theta. So, you will agree with me that AC is the hypotenuse of this triangle. And so, B squared will be equal to the square of this base, which is x squared, plus the square of this height. We'll do the same here. So a squared will be equal to the square of this expression, meaning c minus x squared plus h squared. If we make h squared the subject of the formula in both these equations, it means h squared will be equal to b squared minus x squared. This cx squared taken to the other side will also become a minus, so h squared will be equal to a squared minus the c minus x in brackets squared. Now, notice that both these equations have h squared as their subject. Now, since we can say that h squared is equal to h squared, it means these two expressions on the right side of both of these equations are equal to each other. Therefore, b squared minus x squared will be equal to a squared minus c minus x in brackets squared. Now, our job here is just to expand this part here, the c minus x. Expanding that does not mean we're going to get this square and put it on each of these variables inside. We're going to multiply c minus x by c minus x. So b squared minus x squared will be equal to a squared minus c minus x multiplied by c minus x. So we're going to multiply this c by this c by the minus x. What we're doing here is just multiplying each term of this by each term in this other one. Hence, c multiplied by c will give us a c squared. Notice that this is put in brackets so that we can come and get this negative to affect each of the terms that we're going to find here in the proper way. This c multiplied by the other term in here, which is minus x, gives us a minus cx. Now we come to the minus x multiplied by each term in this other side. Minus x times c will give us another minus cx. Minus x times minus x we can see that we're multiplying by a negative. Two signs of the same kind multiplied by themselves will give us a positive. So we're going to have positive x squared. Now, at this stage, we're going to get these terms out of these brackets. We're doing that by multiplying negative by each of them. Notice that minus cx is going to give us minus 2cx. So b squared minus x squared is equal to a squared minus c squared, the minus and the positive there. Obviously, the minus will win. The minus and the minus 2cx, we've already found the difference here, is going to give us positive 2cx. When we have two signs that are the same, we just write a positive. Here we've got a positive x squared and we're multiplying by a negative 1. So we're going to have a negative x squared. Now our job here is just deciding which of these a squared, b squared or c squared is going to be our subject. We're going to select that by just looking into the two triangles. If you haven't split them, you just look here. Since we've got c minus x in this triangle, the hypotenuse of this triangle will be our subject. Therefore, we're going to get this minus c squared, take it over to the other side of the equal sign, and the rest of these terms. So b squared minus x squared, then we have this minus c squared coming over to this side to make it positive. This will become negative if we cross it over. This will become positive. So we're going to have this expression now. B squared minus x squared plus c squared minus 2cx plus x squared. This expression will be equal to a squared. It's very important to identify the right letter which will be making the subject. If you do it the wrong way, you're not going to get your cosine rule. The easiest is just identifying why you have this expression. Now we just need to get rid of anything that is not playing any role. You can see we've got a minus x squared and a positive x squared. Hence we can say b squared plus c squared minus 2cx is going to be a squared. We're just a few steps away from getting the cosine rule. As you can see right now, this theta here will play no role because so we're going to use this triangle and the cosine theta is equal to a over h to get the value of x. The theta will be a, the adjacent side will be this x. Adjacent means the side next to this angle. The hypotenuse obviously is the longest side in the triangle, the side which is always opposite the right angle. Now making x the subject is not something very big or a big deal, so we're going to cross multiply here or simply multiply both sides by b. Hence x will be equal to b cos a. Now we're going to substitute b cos a wherever we've got an x. Hence we are going to have this variation of the cosine rule. As you can see right from the start, if we substitute this exactly where there's x, we're going to have c multiplied by b. But because we know anything that's been multiplied is commutative, which means whichever the order you arrange the things that are being multiplied, the answer does not change. Hence we write it as 2bc. Now, sometimes it might be useful for you just to learn how to derive it from other altitudes. If you use the altitude from A going to meet the distance CB, there are two formulas that you can get from it. If this side here bears your expression A minus X, it means you'll be making B the subject. If this side here bears the expression A minus X, then you'll be making C the subject. If you get a different altitude, maybe one coming from B going to AC, it means you can have C or A as your subject depending on where you place your expression of B minus X. Enough of the talk about derivation of the cosine rule. Now let's look at an example. In this example, we've been given a triangle ABC where we have AC equal to 8 kilometers, BC is equal to 10 kilometers, and the angle between these two sides we've been given is 92 degrees. It's very simple, so as you can see, we just need to label which side is which. Of course, we know the side opposite A will have the lowercase a or a small letter a. The one opposite B will have B, and the one opposite C will have a small or lowercase c. Now, from this assignment of these opposite sides, we can now understand that we'll be using the third variation, which was c squared is equal to a squared plus b squared minus 2ab cos c. Now we're going to substitute the values that we have. We have the value of a and we have the value of b. We also have the value of c, which is the angle at c. Therefore, c squared will be equal to the a, which is 10 squared, plus the b, which is 8 squared, minus 2ab. A and b are 10 and 8 like that, so we're just multiplying 10 and 8. We put that in brackets, then we include the c. So this is the second part here, 2ab, this is a, this is b, and then c is 92. Now we start simplifying the parts that we can. We're going to simplify these squares, they are the easiest. 100 will be the answer for 10 squared, and 64 will be the answer for 8 squared. So c squared will be equal to 100 plus 64. We can also simplify this without a calculator. 8 times 10 will give us an 80. So 2 multiplied by 80 cos 92. We've simplified a lot of things, but we can simplify further. We can add these before we do anything. So c squared will be equal to 164 minus, obviously, these 2 multiplied by the 8 and the cos 92. Right now we can also find cos 92 so that it can be easier for us to continue working out. Cos 92 is equal to this value here. Make sure your calculator has a small d appearing there, which means degrees. If there's an error, just reset your calculator. You might get different answers. So we have that value. I hope you wrote it somewhere. Now I'm going to subtract 2 multiplied by 80 multiplied by that value we had. Obviously, as you can see, I haven't picked the whole value. I still have my value on the calculator, so I'll be using that value stored on my calculator to perform the remaining of the calculations. Now here, I'm going to multiply this value by the 80. So I'm still going to keep the 164 and the 2. I still have the value of cos 92. As you can see, I ended on this 4 here. I rounded off and gave me no difference there. Now I'm going to multiply this by simply saying my answer multiplied by 80 gives me this new value. I'm going to end it on this 5 here. Now I'm going to multiply this negative 2.79196 by that negative 2. You notice that the sign will change from negative to positive because I'm multiplying by a negative. Again, I'm going to say answer multiplied by that negative 2. It's advisable that you put the negative 2 in brackets when doing this on a calculator so that there's nothing like your calculator solved it the wrong way. As you can see, I have a positive answer, 5.583919472. Again, I store that value just on my calculator. I'll use it later. Now it's time to add the 164 with that. I can do that without a calculator. I know the decimal points won't be affected. It's only me adding the 5 and the 4, which gives me a 9. So c squared will be equal to 169.58392. Obviously, on my calculator, there are still more decimal places. My answer will be much accurate than if I used these values I'm indicating here. Now, I need to get rid of this square here. I'm going to introduce a square root on both sides. What I do on my left side, I do on my right side. So I cancel out the square root on this side, and I remain with c is equal to the square root of 169.58392. I still have my 5 there, so I'm just going to add my 164 to get the 169. As you can see, there are more decimal places. Then I'm going to find the square root of this answer. This answer is very accurate. I'm going to copy it and then round it off to 3 significant figures. This is how we can use the cosine rule. You have finally reached the bonus tip section. In today's video, we've got 2 tips for you. The first is about how you can easily remember the cosine rule. There are 3 variations, but how can you remember all the 3 very easily? Well, let's use the first one to understand the technique. What you observe is that we're starting with the same letter and ending in the same letter. We have A and A. What you notice also is that we have different cases, meaning we start with A, which is meaning side, and a capital letter A, which is meaning the angle found at A. What you see again is that we have B's and C's in this middle part here. We have B squared plus C squared minus 2BC. So the sides that are put here are the sides that are here. If you understand that fully, you should be agreeing with me that this will be our second variation. The third variation has C squared as the subject. So we'll have C, then here we're going to have A and B. We're going to have an A and B here, and then because we're finding C squared, we're going to have C at the end, but it will be a capital letter. That's how you can remember all the 3 variations of the cosine rule without wasting a lot of time. Now, how can we use the cosine rule to find angles? We've got this simple diagram. If you want, you can pause the video and just use the cosine rule and find P. Well, one of the easiest ways is just substituting like I'm from saying. If you see, we've got all the 3 sides. We've got C, which is 275, B, which is 683, A, which is 870, meaning we can put values here, 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 and here. Our only unknown will be the C, and after that we're going to be able to find the value of P. Note that this C is the angle at C. Sometimes your diagrams will even involve other letters such as X, Y, Z, P, R, S, different kinds of letters. You just need to use the same principle. If I have a P here, it means this side will be my small letter P or my lowercase p. If I have Q here, I'll have this side as lowercase q. And if this is R, this will be the lowercase r. One of the fastest ways is just making cos C or the C the subject of the formula. How do we do that? Well, the easiest is getting this minus 2ab cos C over to the other side of the equal sign and making it a different sign. And then getting this C squared, crossing it over to this other side of the equal sign and making it a minus. But I'm not going to do that. I'm going to use simply subtraction and addition. If I want to get rid of this C squared, what I can do is just subtract by C squared on both sides. So if I have C squared, I can subtract on both sides by C squared and get rid of it on my left side. I'm going to put this equal sign here so that you don't get confused which side I'm on. So C squared minus C squared, meaning on my left side I don't have any C squared. This other side I'm also going to include a minus C squared, because what I'll be doing on my left side I should do on my right, and whatever I do on my right side I should do on my left. You also agree with me that we need to get rid of this minus 2ab cos C on our right side so that we can be able to work it out further and get our cos C as the subject. So I'm going to add a 2ab cos C because I know there's a minus before this whole thing. Even on this side, I'm going to add a positive 2ab cos C. Then I'm going to add whatever is left. A squared plus b squared minus 2ab cos C is what is left. Now, what you see is that on our left side, the C squared is normal because we're subtracting C squared from C squared. What you're also going to see on our right side is that because we have a positive 2ab cos C, we are not going to have a negative 2ab cos C. That will also be normal. As you can see, what we're going to have now is 2ab cos C being equal to a squared plus b squared minus c squared. Now it's time we get rid of this 2ab. How can we do that? Notice that this 2ab is combined with the cos C. Therefore, we can't just get rid of it by the subtraction and the addition we did here. This time, because it's multiplied, we're going to use the opposite of multiplication, which is division. We're going to divide both sides by 2ab. Then we can see that the 2ab and the 2ab there cancels. Then we have cos C being equal to a squared plus b squared minus c squared divided by 2ab. Most people can end here and it will be fine, but you can take it further and get rid of this cos here. And we do that by introducing cos inverse on the right side and removing the cos here. So C will be equal to cos inverse multiplied by a squared plus b squared minus c squared divided by 2ab. Thanks for reaching till the end of this video. Keep practicing, working with questions about the cosine rule, and look out for other video which will be about the area of the triangle using trigonometry.